Hi, welcome to another episode of Isabel Explains, and today we're going to be talking about the rules of exponents because I think that you deserve an explanation of where do all these rules come from. Alright, so first let's establish one rule that I see a lot of my students doing, and I just want to clarify this real quick. So let's suppose that we have x squared plus x to the third power. Okay, or minus x to the third power. Let's just start with that. A lot of my students have the, instinct to just, I'll just go ahead and add the exponents, right? And that is incorrect, and I'm going to show you why. So let's suppose that I'm going to make x equal to 2, okay? To make it simple. So if I do 2 to the second power plus 2 to the third power, that would be 4 plus 8, which is 12, right? If I assumed, right, that this would be x to the fifth power, or that 2 to the second power plus 2 to the third power would be 2 to the fifth power, well, 2 to the fifth power is actually 32. So as we can see, 32, 12, not the same thing. And that's why, even if you have the same bases, you cannot add or subtract. So I'm just going to leave that right there. So you cannot add or subtract x squared or any exponent plus or minus x with another exponent. You just have to leave it expressed as that. Okay? Okay, so now that that's out of the way, let's talk about the real rules of exponents, or exponent rules. The first thing that I want to talk about is that we have to have, at least for the first two rules, we have to have the same base, but they have to be either multiplied or divided, okay? So let's start with the multiplication one. Number one, when we have something like x to the second power times, right? At this point, by the way, I would refrain from using x as multiplication sign anymore because you're going to be dealing with a lot of x's and then you might get all confused, okay? So I recommend that you either do an asterisk, is normally what I do, or you can just do the big dot in the middle and make sure it's pretty big so that it doesn't look like a decimal point when you're dealing with numbers. So let's suppose I do x to the second power times x to the fourth power. Okay, the rule says that you have to add the exponents. Okay, when I'm multiplying the bases and making sure that the base is the same, I have to add the exponents. So this would be x to the sixth power. But where does that come from? Well, let's think about what this actually is. So x to the second power is the same thing as x times x. Okay, and x to the fourth power is x times x times x times x times x. Right? I'm not sure how many times I said that. But that's okay. So it's 4 x's, all right? So if I'm multiplying that, all I'm really doing is just multiplying x 6 times. So I have x to the 6th power, all right? All right, so what about when we are dividing the bases, okay? So let's suppose that I have x to the third power divided by x to the second power. Well, the rule says that you have to subtract them, okay? So this is going to be x to the first power, which is just x, okay? So where does that come from? The exact same place that this comes from, because x to the third power is just x times x times x, and we're dividing it by x times x. So we know, this was probably my favorite thing that I learned, right, when I was in high school, was like, oh, if I have it at the top and I have it at the bottom, I get to cancel it out. So this cancels out with that, and that cancels out with that, so I'm just left with x, which is just going to be this guy right here. All right? Now, what happens when the exponent in the numerator is smaller than the exponent in the denominator? Well, let's see. So if I have, let's suppose I have x to the second power divided by x to the fifth power. Well, it's the exact same rule, okay? I'm just going to subtract 2 minus 5, which is x to the negative 3. And that brings me to rule number 3, which is that when you have a negative exponent, it's the same thing as having the positive exponent in the denominator of a fraction. So Another way of me rewriting this, I'm actually going to back up a little bit. Another way of rewriting this is that, again, I'm going to have x times x divided by x times x times x. Ooh, that's 5 of them. Times x. All right? So I get to cancel these 2 at the top, right? With 2 at the bottom, but I still have 3 at the bottom, right? So that is going to be 1, because I have nothing in the numerator, so 1 over x to the 3rd power. And like we just established, this is the same thing as x to the negative 3, because 2 minus 5 is negative 3. Okay? Now this brings me to the 4th rule, which is that if I have x to the 0 power, a lot of my students get this incorrect and they say, oh, that's 0. No, it's 1. Any number elevated to the 0 power is 1. Always. It could be a billion. To the 0 power is 1. I'm going to show you where that comes from. So this is going to be 1. That comes from this, right? Because let's suppose that I have x to the 100th power, right? Divided by x to the 100th power, right? Doesn't matter what this number is, it's always going to be the same number because x is going to have the same value, right? It's going to be the same number top and bottom, right? So we know that a number divided by itself is always 1. And 100 minus 100 is 0. So x to the 0 power is 1. And you can try that with literally any number or any variable. It doesn't really matter. As long as, again, same thing goes for all of these, as long as the base is the same. Okay? All right, so now let's suppose that I have 2 variables, okay? So I'm going to have x and y, okay? Now, x times y is just xy, right? It can just be rewritten as xy. But what happens when they're both being elevated to one exponent? For example, let's suppose that I have x, y, or x times y, elevated to the 4th power. Well, that just becomes x to the 4th power times y to the 4th power. Well, where does that come from? Again, the same thing. So actually, this one is very similar but a little bit different. And what you're really doing is that anything that is in that parentheses is being multiplied by itself 4 times. That means that this is xy times xy times xy times xy, right? Which we know this is a multiplication in itself, so you're just multiplying, right? So this is 1, 2, 3, 4 x's that are multiplied by each other, and this is 1, 2, 3, 4 y's that are multiplied by each other. Therefore, this becomes x to the 4th power times y to the 4th power. Hope that makes sense. Now, the same thing happens if they're being divided. Okay, so if I have x divided by y, okay, and this is all elevated to the 3rd power, is the same concept, okay? So it's going to be x to the 3rd power divided by y to the 3rd power. And why is that? Because the same thing. We have x over y times x over y times x over y, and that is going to be, we know that when we're multiplying fractions, you just multiply across, okay? So this is going to be x to the 3rd power divided by y to the 3rd power. All right, so now let's spice things up a little bit. So what will happen if you have an exponent elevated to another exponent? Don't forget, I promise it's the exact same rules, okay? So let's suppose that we have x to the 2nd power elevated to the 3rd power, okay? Well, think about what we just did. What do you think is going to happen? I hope you said to the 6th power, because this is going to be x to the 2nd power times x to the 2nd power times x to the 2nd power, which is x to the 6th power. All right, and it's because of the exact same rule. Now, if we mix up the rules a little bit, that's when it gets a little bit complicated, but it's not really, because if you know these rules by heart and you really know what's happening, then there's no reason to freak out. So let's suppose that I have x over y, I'm just going to say to the 2nd power here, to the 3rd power here, and this is all going to be to the 4th power. Well, that's going to be kind of hybrid, right, between this part and this part right here, right? So based on these two rules, we know two things. We know that this exponent is going to be distributed to both the top and the bottom, and we know that what that is going to result in is a multiplication of those exponents, okay? So we're going to distribute that 4 to both of them. So I'm going to do x to the 3 times 4 divided by y to the second times 4. So this is going to be x to the 12th power divided by y to the 8th power. And really, that's all there is to it. I mean, you're probably going to come across some exercises that are a little bit more complicated, and all you have to do is just go back to the root, right? Just go back to what is the original rule. How are these rules being applied? And just make sure that, remember, when you're doing additions and subtractions, none of these rules apply. Okay, they apply a little bit different, and I might make another video about that, but those rules are going to be different. Okay? So don't forget to hit like and subscribe, and I'll see you next time.